Oh hey, I didn't see you there. Do you know what all the things you just saw have in common with this? Yeah, that's right, convection. But what is convection? Well, the Oxford Dictionary defines convection as transfer of heat in a liquid or gas by upward movement of the heated and less dense medium. But what I mean? That's what today's video is going to be about. So guys, the concept of hot things rising shouldn't be unfamiliar to you. In fact, we see it all the time with, well, steam rising from tea. But we also see it every day in fluids, where there's uneven heating, right? Something's a little too hot, a little too cold. Let's do an experiment to prove this. Right, so our experiment is very simple. We're going to show that hot water floats and cold water sinks. The two shouldn't mix because they have different densities. All that means is that the particles that are in the cold water are more closely packed together than the ones in the hot water. So, to show this, we're going to fill a container with hot and cold water, separated by a boundary of course. In this case, we're just going to use cardboard. We will dye the hot water red, for obvious reasons, and the cold water green, because I didn't have any blue dye, so I just had to work with what I had. Then, we'll slowly remove the boundary and allow the water to settle. Pretty simple. As expected, the cold water pushed underneath the hot water because it's more dense, and the hot water obviously settled on top of the cold water. An interesting additional observation is that the hot water oscillates on top of the cold water. This experiment shows that the hot water is in fact less dense as the hot water stays on top of the cold water, but this is a stable situation. All that means is that there's no reason for the water to move anymore. But what would happen if the system was unstable, i.e. that the cold water was above the hot water? To achieve the hot water being underneath and the colder or cool water being on top, we're going to place a bowl on top of a stove. Now I've chosen a clear bowl so we can actually see the movement of the water as best as possible. However, please do not try this at home. This could lead to you breaking your bowl or getting injured. So the first time I tried this experiment, you can see that there are ripples moving in the water, but they're moving in a clockwise motion. This is probably because the bowl is being heated more on the left than on the right, causing the left hand side to ascend and the right hand side to descend. Regardless, I put some yellow dye in the bowl just so I could get a more clear understanding of how the flow of the water was. The dye does not go all the way to the bottom of the center. Instead, it pushes out to the sides. This is suggesting that there's upward flow at the center of the bowl and downward flow at the sides of the bowl, which is convection. I tried this experiment a second time, and you can see more clearly the upward movement of the water at the center of the bowl. It's hard to see if there's any descending water, however, it's likely the descending water is along the sides of the bowl, as there must be some water moving in to replace the hot water rising. Right, so remember how I said this happens in our atmosphere as well? Well, when I'm talking about localized convection this, localized rain that, that's because it's the same type of motion in our atmosphere just over our island. Now, you probably know that things heat up faster and slower depending on the material. Well, in our case, that's the land. The land heats up faster than the surrounding water. So because the land is hotter, it radiates out some of this heat and heats up the air above it, meaning the air above the land is hotter than the air over the water. This means that the air over the land is less dense and will therefore rise. As it rises, it pulls in the air from over the water because nature hates a vacuum, and then this new air above the land then gets warm, and then that rises. And you get a continuous cycle. This is convection. Now this is not the only example of convection in the atmosphere. We also have thunderstorms. And on a larger scale, we have hurricanes. and there are plenty of other examples of both large-scale and small-scale circulations caused by convection. Right guys, that's it for today's video. Hopefully now when I use the term convection, you guys actually know what I'm talking about. But guys, as always, make sure to follow us on our social media so you can get up to date with the latest weather information and learn some things or two. And as always guys, stay safe. Oh, why am I wearing an apron? Doesn't everyone?